OpenAI put some of its strongest cyber models inside a sandbox with no direct internet access. The models found a zero day in the one path, allowed for packages, climbed through internal machines, reached the open internet, and helped compromise Hugging Face to steal benchmark answers. Hugging Face later reconstructed more than 17,000 recorded events. The frightening part is not that the AI became evil, it is that one useful opening was enough. This was an internal cyber evaluation, with production safeguards intentionally reduced. It does not prove that an ordinary coding agent can repeat the attack. But it does expose the right question for every agent on a developer laptop. What can the harness reach after the model decides a path is useful? The evaluation was Exploit Gem, a benchmark built from 898 real vulnerability cases. Package installs passed through an internally hosted package registry cache. OpenAI says the models discovered an unknown flaw in that proxy, then used privilege escalation and lateral movement until they reached a node with internet access. Once outside, the goal did not change. Find the benchmark solution. OpenAI says the models inferred that Hugging Face might host the answers, then relied on stolen credentials and additional vulnerabilities to find remote code execution. Hugging Face reported limited internal dataset access, affected service credentials, and no evidence that public models, datasets, packages, or container images were altered. Four things combined: a highly capable model, a narrow goal pursued for a long time, a containment design with an exploitable dependency path, and vulnerable systems beyond that boundary. Remove the science fiction, and the lesson becomes more useful. Security depends on the harness, not on whether the model sounds trustworthy. A normal container answers a smaller question: which files and processes are isolated from the host? An agent sandbox must answer more. Can the process call the internet? Which credentials did it inherit? Which package managers, browsers, connected tool servers, cloud tools, and approval paths can it invoke? A box around files is not a box around agency. So I rebuilt only that architectural weakness. No exploit code, no real token, no outside target. Both environments received the same harmless task and the same read-only project: find the answer file. The first environment also inherited a dummy credential and a path to a local mock service. The second removed both and enforced network denial with the operating system. The file-only sandbox looked safe. The project could not be changed. But the process found the dummy token, contacted the mock service, and completed the task with an answer from outside the workspace. One external request. File system isolation worked exactly as configured. It was simply solving the wrong security problem. The contained run completed the same task from the approved answer file. It inherited no credential. It made 0 external requests. A separate probe then tried to reach the mock server from inside the same operating system profile. The connection failed, and the server saw nothing. Same goal, same files, different authority. This reconstruction is deliberately boring. A scripted stand-in is enough because the result comes from architecture, not intelligence. Any process with a token and an allowed route can cross that route. A stronger model only makes it better at discovering paths you forgot to include in the diagram. For Code X, Sandbox and Approval are separate controls. Current local defaults keep command network access off and writes inside the active workspace. Cloud agent phases are offline by default, and configured secrets are removed after setup. But full access, broad network rules, additional writable directories, or tools with external side effects change that boundary. Check the active profile, not the product name. Claude Code and Quen need the same audit. Claude exposes tool allow and deny rules, permission modes, proxies, and a dangerous permission bypass. Quen offers open, closed, and proxied sandbox profiles. Its default macOS permissive open profile restricts writes but still allows outbound network access. The word sandbox does not describe one universal security level. A real containment checklist has 9 lines. Narrow file system mounts, network denied by default, no ambient credentials, minimal tools, unprivileged processes, package installation isolated from the agent phase, external content treated as untrusted, human approval at privilege boundaries, and a complete action log with revocation and rollback. Miss one, and that line becomes part of the agent's reachable world. A container can protect your laptop and still leave the agent a route to the rest of your company. A permission prompt can delay a step and still expose a secret, the process already inherited. The verdict is simple. A container is not automatically an agent sandbox. Containment is the complete set of things the agent cannot reach, even when reaching them would complete the task.